Hello everyone, welcome to another Quad Education Test Prep Fundamentals video. My name is Tom, and today we're going to be talking about a topic from the SAT and the ACT that can show up in some of the trickier geometry problems. On first glance, it may look a bit intimidating, but I think if you stick with us, we'll be able to demonstrate that it's really not that bad, and it makes intuitive sense as well. That topic is circles, specifically sectors of a circle, so let's take a look. All right, let's run through some simple circle identities before we dive into this sector thing. So you've got your area of the circle, which is pi r squared, pretty straightforward. We've got our circumference, which is 2 pi r, or pi times the diameter, because 2 radii are the same thing as the diameter. And finally, 360 degrees, which is the number of degrees in a full turn in a full circle, is the same thing as 2 pi radians, which is just another unit of measure for angles. Moving on to today's material, we're looking at sectors of a circle. So a sector is a segment of a circle which is formed by basically drawing 2 radii, which is the distance from the center to the outside of the circle, to make this little segment here. I like to think if the circle was a pie, then this would be a slice out of the pie. So sector is just a slice out of the pie. And there are 3 properties that we want to be thinking about when we inspect a sector of a circle. And those are the angle measures, that's the interior angle measure of those 2 radii, what they create. We often use the Greek letter theta for that for some reason. And the next one is the arc length, which is just the distance along the circumference in this sector. And finally, there is the area of the sector, which is just how much area of that full circle is enclosed within that sector. And for all these properties, we have this big equation over here, which relates them all together. So before we dive into this mess, I'll ask you this. How symmetrical is a circle? Well, infinitely, completely, totally, absolutely symmetrical, right? And so if that's true, it would stand to reason that each of these segments are in proportion, which is to say, the proportion of 360 that angle is there is the same proportion that the arc length is of the entire circumference. And that is the same proportion also as the area of the sector as a part of the area of the entire circle. So keeping that in mind, this will start to make a bit more sense. So looking at this example over here, I've used 90 degrees just sort of as a nice visual representation of how intuitive this can be. So since this is 90 degrees, 90 degrees out of 360 degrees is pretty clearly a quarter of the whole circle. So if the radius was 10, well, what would that mean that the circumference would be? Well, circumference equals 2 pi r, so that would just mean that the circumference is 20 pi. And we're saying that the sector is a quarter of the whole circle, so we just take a quarter of 20 pi, and that is 5 pi. And if we thought about the area of that sector, well, the area is pi r squared, so 10 squared is just 100, so 100 pi is our area. And if we take a quarter of that, that's 25 pi. And you could do a bunch of complicated cross multiplication, especially if this proportion was less friendly than a quarter. Usually it will be pretty friendly because they kind of want you to just keep moving. But you can see intuitively, if you're thinking about it this way, that you don't need to do a bunch of cross multiplication in algebra. You can just say, hey, it's just that proportion to find what those properties are of that sector. The key here is to not get lost in all these equations and fractions. As you can see from the example, the trick is to just get the proportion. And you can only do that if you have a part-whole pair. So that can be one of 3 things. That can either be the sector angle, and you always have 360 because that's how many degrees are in the circle, or you can have the arc length and the circumference, or you can have the sector area and the circle area. But once you have one of those pairs, you're in really good shape and you're good to solve any of the other properties. So let's do an example problem and I'll show you what I mean. All right, take a look at this example problem. I've gone ahead and given you the clue to the equation as well as a circle that you can use as well there. But see if you can't read this question and get a good answer. Okay, let's take a look at this problem. So it says, for a sector of a circle with arc length of 3 pi and an interior angle measure of 60 degrees, what is the area of the sector? So I'm going to go ahead and sketch in what that sector might look like just for visual reference for me. Looks about like 60 degrees. And I'll draw in that I know that this is 60 degrees here. And then I will label 3 pi as the distance of that arc there. And then I can start filling things into my equation. So I want to get to a pair, and since I only have the arc length, that's not going to do it for me for the arc length circumference bit, but I do know 60 degrees, and I will always know that 60 degrees is part of 360 degrees. So that's just 1/6. So whatever this arc length is here, it's just going to be 1/6 of whatever the circumference is. And since it's pretty easy to go backwards from 1/6, you just multiply by 6. We can just say 3 pi over 18 pi right there. And that is going to give us our circumference. And so we can just sort of sketch over here. Circumference equals 2 pi r, 18 pi equals 2 pi r, which pretty clearly indicates that the radius is 9. And so then moving on to the area part, well, we're going to need to have the area of the whole circle first. And we can write down our area of a circle equation over here. Area equals pi r squared. And 9 squared is equal to 81 pi. And so we have 81 pi right here. And then we're going to need to divide by 6 to get to the area of that sector. And you kind of think about it, 81 doesn't exactly divide by 6 nicely, and that's definitely by design. We do know that you can divide 81 by 3, though, so we can take out a 3 in that denominator. And 81 divided by 3 is 27. So 27 pi over 2 is going to be our answer there. So hopefully that made a lot of sense, and hopefully that was helpful. Okay, that's it for this video. If you're having trouble remembering that sector of a circle equation, just keep in mind part over whole equals part over whole equals part over whole. And also, there are no 2D shapes more symmetrical than a circle. If you found this material useful, we hope that you will like, share, and subscribe to Quad Education. Thank you for watching, and I hope you have a great day.